Hi. So here are questions 3, 4, and 5. And in question 3, what we want to do is we want to try and find where this function, knowing its derivative, finds a relative minimum. So again, whenever we see that relative minimum, when does f prime equal 0? And it has to change from negative to positive. So let's make a number line. The number line that I'm going to make are the zeros of the derivative. So I'm going to make a note that this is a derivative number line. And when will this equal 0? Well, I'm going to have a 0 at positive 1, negative 2, and positive 2. I lied. Positive 1. So at positive 1, negative 2, and positive 2. We now need to pick an x value that is not one of these three. So I'm going to pick 0. So if I go to plug in f prime of 0, I'm looking for what is the sign of 0. 0 minus 1 squared is positive. 0 plus 2 to the third is positive. 0 minus 2 to the fourth, well, a negative number raised to an even power would be positive. So f prime of 0 is positive. Now it doesn't matter which way I fill in these signs. I'm going to go to the left side of negative 2. So negative 2 came from this factor, and the exponent of that factor is odd. So because that exponent of this factor is odd, whatever the sign is on the right side, it's going to be the opposite on the left side. Positive 1 comes from this factor. The exponent of that factor is even. So whatever the sign is on the left side, it's going to be the same on the right side. Positive 2 came from this factor, and the exponent of that factor is even. Since it's an even-powered exponent, I'm going to have no sign change. So where does my derivative change from? Negative to positive? My derivative changes from negative to positive at negative 2. So for what value of x? X equals negative 2. Since f prime changes from negative to positive. You're going to need a little bit more space for this one. All right. So the only difference between an absolute and a relative is that the absolute is we're comparing the y values. And an absolute maximum can happen at two types of places. An absolute can happen at locals and at the endpoints. So let's find any x values of a local maximum. So at a local maximum, f prime is equal to 0, and it changes from positive to negative. So what is the derivative of this function? It is equal to 0. Well, both of these have a 3x. So I'm going to get derivatives of the, or zeros of the derivative at 0 and 2. We now need to test a value. Let's test 1. And when I test 1, f prime of 1 is equal to 3 times 1 is positive, 1 minus 2 is negative, so we have a negative. This exponent is odd, so on the left side of 0 there's going to be a sign change. On the right side of 2 there's going to be a sign change. Where do we have a maximum? when it changes from positive to negative. So there's a local max at x is equal to 0. So now we need to compare the y values of 0, -1, and 4 to determine where the absolute maximum is. So what is the y value at 0? If I want y values, I need to go back to this function here. So what is the y value when x is equal to 0? 0. 0 cubed minus 3 times 0 is 0. What is f of -1? F of -1 is equal to -1 to the third minus 3 times -1 squared, which is equal to -1 minus 3, which is -4. What is f of 4? Um, 16. So which one of these is the largest y value? Well, 0, -4, and 16. The absolute maximum of this on that interval is 16. Okay. The mean value theorem is when the average is equal to the instant. So the average is equal to the instant. Average rate of change, instantaneous rate of change. So we need to find the average rate of change from 0 to 4. So what is f of 4 minus f of 0 over 4 minus 0? F of 4 is equal to 1/2 times 4 squared minus 3 times 4 plus 2. 8 minus 12 plus 2, -2. F of 0 is equal to 2. So we have -2 minus 2 over 4. -2 minus 2 is -4 over 4, which is -1. The derivative of this function, f prime of x, is equal to 2 times 1/2 is 1, so x minus 3. And then the derivative of 2 is 0. So we're looking for the particular value c where these two things are equal. So we want to know when are these two things equal to each other. So we have -1 equals, and we're looking for the specific value of x, so we're going to change that to c, add 3 to both sides, c is equal to 2. Now, because this says Rolle's theorem, what do we know about the average rate of change? We know that the average rate of change is equal to 0. So we can just say, when is that derivative, c minus 3, equal to 0? When c is equal to 3. Because if we went to go do f of 6 minus f of 0 over 6 minus 0, that is going to equal 0, because that's the special case of the mean value theorem, where that average rate of change is equal to 0. And then this is the place where the x value of 3 is the place where that derivative is equal to 0. Okay, hopefully these were helpful. We have a couple more coming up, and I'll see you in the next video.